Today, as has been alluded to, I'm going to be talking about public transit ticketing systems. But before I go into that, I'll give a little intro about myself beforehand. So during the day, I work as a software engineer at Skyscanner, building payment systems. Last year, I finished up uni at Abertay doing ethical hacking. Recently licensed as an amateur radio operator. And I probably have this really strange accent because I moved to Scotland 4 years ago, lived in the Dominican Republic before that, and lived in Southern California before that. I'm really keen on investigating the interaction between security and user experience, interested in embedded devices, certainly in payment technologies, and also really keen on public transportation, to the point where before the coronavirus all kicked off, I used to give National Rail far too much money on a regular basis, which is what inspired the whole reason for this talk. So this talk is an overview of the research that I did for my honors dissertation, plus some later post-uni work that was done afterwards. So if you often visit major cities, you probably have a drawer that's loaded with different transit cards in it. So in this drawer, I've got some transit cards from different parts in North America and some parts of Europe as well. And these cards are all incompatible with each other. You can't use them across different cities other than the ones that they were issued in. And so if you travel around a lot, you're just kind of forced to accept that you're going to end up having a drawer that's full of these. Now, of course, in 1998, the UK's Department for Transport, which is the government body that is in charge of regulating public transit and the roads and the like in the UK, formed this organization called ITSO with the idea of developing an interoperable smart card scheme for the UK. And essentially back in the late 90s, they foresaw that this was going to be a problem and thought, okay, let's build a standard that all the cities in the UK can just use. We'll make this really great once, and that way people will only have to carry one card around regardless of where they travel to in the UK. And ITSO has been in use in the UK for a good while. So in England, their national concessionary travel scheme started using ITSO in 2008. In Scotland, ITSO is used to provide, also through the concessionary travel schemes, free travel for people over 60, as well as discounted travel for people between 16 and 18. With a plan to make travel for 16 and 18-year-olds free in Scotland as well. Additionally, ITSO has been mandated for any new smart card schemes being used by train operating companies by putting clauses requiring its use in their rail franchise renewal agreements. So my whole interest with ITSO kicked off because when I moved to Scotland, I was issued with one of these wonderful student cards by Abertay. So this is what the front and the back of my student card looked like. And shortly after I received my student card, I noticed that it had this interesting ITSO logo on it. And I was curious as to what this would allow me to do with my student card. And it turns out there's quite a bit. So in addition to the regular functions that you would expect me to be able to do with a university issued smart card, I could also load both local bus tickets as well as bus tickets that were valid across the greater Tayside area, as well as being able to actually go through to Glasgow and load subway credit onto my smart card, just using the exact same student card that I had been issued in Dundee, but still being able to use it while I travel. Unfortunately, this all ended up coming to a halt because the student card that I was using ended up being unsupported in terms of the underlying NFC chipset that the smart card was being used. And so I ended up not being able to travel on it the next time that I visited Glasgow, and had to ask the Glasgow subway operators for my money back onto a different smart card. But of course, this was back in 2017. So you would hope that things have gotten better in the 3 years since then. And indeed, Transport Scotland did begin a national campaign encouraging commuters to use smart cards back in November. So you would hope that, given that they've been pushing for people in Scotland to use smart cards more often, that at least the situation has improved up here. So I went back to SBT's website, given that they were the organization that I was having the most trouble with at the time, and they advised that I should check directly with my operator to determine whether smart cards are compatible across different service operators. So I went ahead and did that, and I also went ahead and checked with all of the operators that I could find that were issuing smart cards in Scotland. Unfortunately, the compatibility matrix for this is a bit of a disaster and is quite far from this universal compatibility dream that was being envisioned in the late 90s. So why did we end up in this place where there are so many different organizations issuing these smart cards that aren't compatible with each other? And what was it supposed to look like anyway, right? I mean, because this means that in practice, I now have a drawer just for UK smart cards that are all meant to be technically compatible with each other. But okay, fine. So let's take a step back for a moment and let's think, how was this supposed to work to begin with? And as an ethical hacking student, I was particularly curious to understand whether anyone had actually gone and checked whether this standard was secured or not. Now, being that ITSO is a publicly funded project, you can freely download the core ITSO spec from the website. So you get all these wonderful PDFs that describe the different parts of the ITSO ecosystem, and you can just go and download these online. And the core idea behind the scheme is that you should be able to have different products coexisting on a given smart card without prescribing an underlying technology. So what this means is that ITSO is able to support smart cards that are manufactured by different companies that use different underlying chipsets. So it supports MIFARE Classic, Ultralight, Desfire, and it even has its own custom chipset scheme. And indeed, you can see that different issuers definitely do take advantage of this in the sense that the technologies that are being used across different smart card issuers does vary quite a bit, with some using Ultralight for disposable tickets, using Desfire for more robust tickets nowadays. And the way that ITSO is able to accomplish this is by separating out the responsibilities for each part of the data model process. So it considers the customer media, that is the physical layer, the smart card that's holding this information, separately from the shell, which is a region of memory that's been allocated on the smart card for ITSO data, separately from each of the product entities, which contain information such as travel entitlements or pay-as-you-go balances. And ITSO organizes every piece of information that's on a card inside of this structure called a data group. And these data groups have a label, which is a sort of header. They have the data set, which is then the actual information that's being stored, a unique identifier, as well as a cryptographic seal, which I'll touch on a bit later. These data groups come together to form a product directory within this memory region on the smart card that's been allocated for ITSO. So the way that this works is that the directory is just a fixed region in memory that has a list of all the different memory regions where the different products can be found. And so the card can just go through while this information is being read and just iterate through and find all the different products. And a similar mechanism is used to provide a logging mechanism in the specification. And this log is used to keep track of when you tap in and tap out, when you top up, and various different operations that you could perform on this card. And similarly, you just have a list of locations in memory that you want to point to. And when you read the card, you can then reference those to look up the underlying data that's being referenced. Now, because ITSO has to support all these different chipsets, they're not really in a position where they're able to rely on whatever security is provided by the actual chipset. So in these NFC smart cards, there's usually some sort of cryptographic mechanism available for, at the very least, access control, so that you can control who can read and write information from your smart card. But since ITSO has to be compatible with all these different chipsets, it implements its own cryptographic scheme on top of that, so that you don't have to rely on the chipset as your only mechanism for integrity. And the way that ITSO manages this cryptographic scheme is through a hardware security module that it calls the ITSO Secure Application Module. And essentially, this secure application module holds a private key and holds information about the different cryptographic algorithms that ITSO uses. And this hardware security module is then able to validate tickets that are stored on a smart card, as well as write new tickets to a smart card using the private key that has embedded inside of it. And so as a result of this, the secure application module is really important to the ITSO ecosystem. So things like ticket vending machines, ticket barriers, and in theory, the handheld readers that conductors have should all have one of these inside of them, because otherwise they can't write or verify information on the card. There's additionally another mechanism called the remote point of sale terminal, which allows you to use a hardware security module that's connected to a server over in the data center somewhere, and then you can access that over the internet without having direct access to the secure application module. And this is something that you might recognize if you have used smart cards personally as Remote Ticket Downluuu. So this is where you can use usually your mobile phone to download smart card tickets that you've already purchased onto your smart card. So an example of how this works is holding my smart card up to my phone. It goes online, tries to find updates, and then just doesn't find any. But I still have the option to see what tickets I have on this card. Now, the really awkward thing is that the ISAM operation is literally the only part of the ITSO spec that's covered by an NDA. Everything else about the specification is freely available online. You can just download it and the link that I had mentioned before. But unfortunately, you just cannot get any information about the ISAM. You have to sign an NDA to get access to it. You have to actually be working in industry. And even from folk that work in industry, this is still something that's very much kept as a closely guarded secret. But thankfully, because we have all this detail about all the surrounding bits, we can still understand the overall mechanics being used to secure the system, despite not having access to the actual algorithms being used. So in order for ITSO to gain secured access to a smart card, it needs to be able to derive authentication keys to read or write data from the smart card. And so because it supports all these different chipsets, there are various different mechanisms available to generate these keys. And it needs this initialization information off the smart card in order to generate these keys to begin with. But of course, this creates a kind of catch-22 where you need access to the card data in order to get the encryption keys so that you can read the card data. So the ITSO specification developers recognize this as a limitation and decided to simply make all of the data on ITSO smart cards freely readable. So this is absolutely brilliant as a hobbyist, because it means that you can actually completely legitimately read all of the information on an ITSO smart card using keys that are just freely given out. And this means that you can freely take a look at anything that's just stored on that card. But what's disappointing is that despite having this freely readable nature to the smart cards, there are no open source implementations that would let you read the information off a card. So I went ahead and wrote one. Using the publicly available documentation, I was able to build some Python tooling for the card data. And at the base level, this presents a command line interface, which allows you to see what smart cards are visible to the NFC interface, and then goes out and prints some information that it was able to get off the smart card to the terminal. But this command line interface isn't super interesting. And what's more interesting is the actual API interface that this provides behind the scenes. So here's an example of a small Python script that I've written that will connect to a smart card, read through the products that it has stored on it, try to find a pay-as-you-go wallet for the Glasgow subway, and then we'll print out the transactions that it can find for it. And PyTravelCard's been designed to print out as much information as it can about the object. But it stores this internally within the structures that still have the raw bit mappings. So as you're looking through this in a debugger, you have an opportunity to sort of better understand the relationship between the raw card data and the actual interpretation of the card, just because the two are right next to each other. So now I'm going to do a fairly short live demo of how this works in practice. Let's see. Okay. So just to prove that there's nothing weird going on, I'll just run PyTravelCard scan with nothing on it. And of course, that's not found. Oh, no. Right. So there are no tags found at the moment, just because I don't have anything next to the NFC reader, so that's fine. So when I go and actually put a tag on the reader, I can go ahead and run scan again and see that there has actually been a card found now. And if I go ahead and run my demo script, I can see here that I've tapped into the Glasgow subway at about 8:30 and tapped out at 9 minutes later. And this is real information that's being printed off directly from the actual smart card connected to my computer at the moment. So that's really neat. And it's really neat to be able to statically read that information. But there are some apps in particular on the Google Play Store that allow any member of the public to sort of already do this. You can already go through and get these apps for an Android phone and read what information is stored on an ITSO card. So because my student card was issued as a MIFARE Classic smart card, and we've known for a very long time that there are tons of vulnerabilities inside MIFARE Classic, I was really curious to see what I could do in terms of tampering with the data on the card and still see whether it would be accepted as valid. So what's being shown on the screen here is an actual cloned MIFARE Classic card. So on the left side here, it says unknown manufacturer, whereas my real student card was manufactured by NXP. And yet this smart ticket checker still reports the card as being valid. So already that's not very good, given that this has been cloned. But the other awkward thing is that, so as I had mentioned before, you can't check whether these cards are valid or not without access to the special hardware security module. So I went ahead and changed the expiry date to a date earlier on in this year. It previously expired in 2016, so gave myself a little bit more time. I went and changed the serial number to be all ones as well. But of course, this is still being reported as being a valid card. Unfortunately, this is a section that I will not be providing a live demo for because the Computer Misuse Act of 1990 would forbid me from facilitating others to do naughty things with public transit cards. But despite this being a MIFARE Classic card, and despite this being, the sort of chipset that's not really in active use anymore, it's this sort of greater vulnerability is still present in the ecosystem, in the sense that conductors for a local train company often use their corporate phones, which don't have access to this hardware security module, for ticket validation. And due to Scotland's rugged nature, can't rely on mobile data always being available. And I think this is a really interesting example of where this requirement to have this specialized equipment has meant that this validation just directly isn't happening. Most of the chipsets used now are these Desfire EV1 NFC chipsets, which don't have any publicly known vulnerabilities. But considering that ITSO's flagship security mechanism isn't even being used for validation most of the time, you sort of have to wonder whether the scheme has been a success in terms of delivering its security goals. And I think in particular that ITSO is a bit problematic in the public transit space because it's flexible but in directionless manner. It allows public transit operators to just lift and shift whatever tickets they had been printing on paper for years without really thinking about how smart card technology would allow these tickets to be sold in a more traveler friendly fashion. So, for instance, here is the Association of Train Companies 158-page long manual on how to map all these different national rail tickets to smart products. And you begin to wonder, well, wouldn't it be better to actually build something from the smart card scheme rather than trying to adapt what we currently have poorly onto a system that's capable of a lot better? And so I sort of question, if not ITSO, then what would we have instead? And ideally, I'd love to see us having more in the way of e-tickets. So the sort of tickets that you could print out on an A4 sheet, display as an email on your phone, or display through Apple Wallet or GPay. It'd be great to see ITSO being used more for pay-as-you-go as well. I don't think these sorts of schemes where you have to buy a single journey ticket, load them onto a smart card are a good use of the medium at all, when the whole point of the system is that we should be using computers to do the heavy lifting for us. And I think Transport for London are a really good example of a transit agency that have just absolutely nailed this concept of smart ticketing. Back in 2003, they introduced Oyster, being one of the first transit agencies in the world to do smart ticketing. They introduced pay-as-you-go journeys for buses and rail the year after. They were one of the first public transit organizations in the world to do automatic price capping, wherein if you travel a certain number of times a day, the system will just pretend that you've bought a day or a week season ticket and not charge you the difference. They've got pay-as-you-go on all of National Rail there right now. And after being the first public transit operator in the world to accept contactless bank cards, they now process 1 in 10 of the UK's contactless transactions, to the point where they've actually licensed that technology out to Cubic, who are rolling that out in a bunch of cities across the world. And the core message that I'd like to get across here is that I think that computers allow us to scale problems that we'd otherwise engineer much better solutions for, because it's way easier to just throw machine brute force at a problem than it is to return to a whiteboard. And I'd really wish that transport agencies would stop asking, how do we migrate these paper tickets to smart cards? And instead start asking, how can we leverage the unique benefits that smart ticketing provides us with? I also just want to take a moment to acknowledge all these wonderful people who have meant a lot to me while I spent the better part of a year of my life doing this research. And most of all, I'd like to thank you, the audience, for listening to me ramble on for the better part of half an hour. And I really hope that you've enjoyed what I've had to say today. And at some point later on this week, the slides for this will be available on that website. So thank you very much.